This is CS1101 Lecture 13.3, our last lecture. We're continuing our discussion of objects, polymorphism, and adding in a discussion of dynamic binding. So we said a chain of derived classes is going to permit us to reuse more code and prevent redundancy, and thereby improve our efficiency. And it's referred to as multi-level derived classes when we have a chain of hierarchy, right? So a undergraduate is a student so student extends person, undergraduate extends student. But let's consider our example. Every undergraduate is a student, and every undergraduate is a person because every student is a person. Then we said, if that's the case, then we can use a reference to an object of class undergraduate, right? We can have a reference variable to an object of class undergraduate, and we can substitute it for either a reference to an object of class student or a reference to an object of class person. So we can have an undergraduate reference variable and pass it to some method that expected a student object or a person object. Since we can do this, it's clear that an object of type undergraduate actually has more than one type. And this idea of having more than one type is called polymorphism. The term polymorphism is broken into two root words, poly and morph. Poly being many and morph meaning shape. So this is a many-shaped or many-typed object. So polymorphism is when one object can be substituted for another object. So one object can take on multiple shapes or multiple types in this situation. The reason that we can do this in Java is because of this idea called dynamic binding, which we'll talk about further after we go through some more discussions regarding polymorphism. So consider this. Let's say we have the following declaration in the student class called compare GPAs. And this method is going to just compare these two students' GPAs to see which is higher. By the virtue of this dynamic binding and polymorphism, all of these calls here and here are valid calls. So notice that this was declared with a type student parameter for S1 and S2. So Java expects a student object to be passed to S1 and to S2 in the compare GPAs method. However, we're able to pass a student object and an undergrad object or two undergrad objects instead. The reason is because an undergrad object is a student object. So this undergrad object is also a student object, as is this undergrad object. So we are able to pass an undergrad object into a parameter which expects a student object because of polymorphism. And it will not interrupt or break the methods. We already made use of this a little bit when we were overriding the equals method, if you remember. We said that this code right here is a little bit weird when we call super.equals and then pass it undergrad. What we are doing is we are passing the student equals method an undergrad object. However, if you remember, inside of the student class, the first thing that we're going to do is check to see if the object that was passed in is an instance of type student. So we're passing the equals method in the student class an undergraduate object. And we're going to compare to see if it is a student object. Why is this going to work? The answer is because of polymorphism. Because an undergraduate object is a student object. So instance of will return true when we check to see if an undergraduate object is an instance of student. So this actually will have a domino effect when we wind up with a multi-level class hierarchy. So in the case of undergraduate is a student is a person. So remember, in the student class, we allowed the super.equals method to actually check the name. So the person.equals method, or the .equals method that is part of the person class, is actually being used to check to see if the names are the same between the implicit parameter and this student object that has been passed into other. So then when we call undergraduate.equals, so we use the equals method built into our undergraduate class, it calls the equals method, which is part of the superclass student, which calls the equals method, which is part of the superclass person. So the undergraduate object got passed in to the student equals method, and we checked to see if this object of type undergraduate was an instance of type student, and it said yes. And then we passed it into the person equals method, and we checked to see if this undergraduate object was an instance of type person, and it said yes. So we can domino effect all the way back to our most primitive class, our person class, and find that, yes, in fact, Java considers an undergraduate object to be an instance of a person object as well as a student object. A big point here, though, is that it doesn't go both directions. So even though we can substitute a student object into anywhere we want to make use of a person object, we can't substitute a person into any situation where we expect a student. And the reason is, if you think about it logically, the is a operator, right? So undergraduate is a student, student is a person, doesn't work in both directions. So a person is not necessarily a student. A student is not necessarily an undergraduate. So therefore, if a method expects a student object, we can't pass it a person. So you have to make sure you understand the inheritance hierarchy, because it only goes one direction. Yes, we can pass an undergraduate object into a method that expects a person or a method that expects a student. However, we cannot pass a person object into a method that expects a student or an undergraduate object. So in general, a reference to an object of an ancestor class can't be substituted for a reference to an object of a derived class. So an ancestor object in this case would be the person class, while the derived class would be undergraduate or student. You can't pass an ancestor into a reference expecting a derived class. So going back to our compare numbers or compare GPAs, we were going to pass in two students and compare their GPAs. We said we could pass in student objects or we could pass in undergraduate objects. However, we can't pass in person objects, because a person is not necessarily a student. Can't use ancestors when you're expecting a derived class. We can always use a derived class anytime we're expecting the ancestor, but you can't turn that the other way around. So anywhere that you expect to pass a person, you could pass a student or an undergraduate. But if you expect an undergraduate, you couldn't pass a person or a student. It has to be the undergraduate. This only works in one direction. So going back to this idea of polymorphism, we said that we could pass a reference to a derived class into anywhere expecting the ancestor class. So anywhere where we expect to get a person, we could pass a student or an undergraduate. Well, the same thing is true of variables, reference variables that are declared. So we can declare some reference variable called P and some reference variable called S. And we will assign S a new student object. And we will leave P uninitialized. Then we assign P the reference which is stored in S. So now the reference variable which is intended to point to a person object holds a reference to a student object. And that's okay. That works. We can pass a student reference into a person reference because a student is a person. However, in any uses of the variable P, you can invoke only methods of the class person. So you couldn't use any of the methods which are defined at the student class level. You would have to restrict yourself to calling the methods which are available at the person level. So you could do get name, but you couldn't do get student ID. So you could say p.getName because getName is a method which is declared in the person class, but you couldn't call p.getStudentID because getStudentID is declared in the student class. However, that does not mean that when we use p to call a method such as toString, that we will use the toString method defined in the person class. No, since this is an object of type student that has been stored into a person reference variable, then we have overridden the toString method, which is declared at the type person, and we've replaced it with our student toString method. So when we call p.toString, we're actually going to call the toString method which is declared at the student class, in the student class. So if you assign a derived class object to a ancestor class reference variable, then you must restrict yourself to using the methods that are available at the ancestor class level. However, a call to one of those methods may actually wind up calling one of the overridden versions of that method. As an example, we can say p.getName, but we can't say p.getStudentID because getName exists at the person class level while StudentID does not. We can say p.toString as well because toString exists at the person class level. However, it won't call the toString method that is declared in the person class. It will call the overridden toString method at the student class. So to say that one more time, different objects may invoke different method definitions using the same method name. As an example, let's say we have P1 and P2, both of which are of type person. But later on, P1 is assigned a reference to a student object, and P2 is assigned a reference to an undergraduate object. Then when we call P1.toString, we'll actually invoke the student toString method definition, whereas the P2.toString will actually invoke the undergraduate toString method, even though both P1 and P2 were declared to be type person. What controls which method is called is the actual type of object which is assigned to that reference variable. So, if a method is overridden in the class student, and we have a reference variable P of type person, which references a student object, then the method in class student is used when we call p dot equals or p dot toString. The variable determines what methods can be called, but the type of the referenced object determines which definition of the available methods will actually be executed. This is an important thing to make sure you understand and know. This feels like a good test question, right? So declare a couple of different variables of a couple of different types, start assigning them around, and then calling methods and ask what will be printed out. And it's going to be determined by, first of all, the available methods will be determined by the type of the reference variable, but which version of the method is actually used, so which definition of the method is used, will be determined by the type of the object. So make sure you understand this concept. So the property of Java that allows for handling these invocations of some method that might be overridden later is called dynamic binding. So the idea is this: the type of object which is being referenced when the method is called determines the method which is invoked, not the type of reference that was declared. Even though P was declared as type person, if we assign it a reference to a student object, then when we call p.toString, it's going to use the toString method definition in the person class, because the actual object which is assigned to P is of type student. So how is this useful? Well, it simplifies code. Imagine that we had some array, the university had some array of type person, such that everybody who's affiliated with Vanderbilt is stored in this array. However, some of those people are undergraduates, some of them are graduate students, some are faculty, and some are staff. But then we had this method which was declared in the class person, but then was overridden in each of the different specific derived classes. Then when we call monthly update on each of the individual people in our person array, the actual actions taken, the behavior of that method will be different, even though the code is very simple. The code will just be a for loop that processes each individual element of the array and calls the monthly update method. However, what actually happens, the behavior of that call, will depend on what type of person it is. If it's an undergraduate, then they'll be charged monthly fees. If it's graduate students, they're awarded their monthly stipend. If it's faculty, they'll receive their monthly paycheck, and so forth. So then, rather than having to code all of this explicitly and individually, by using inheritance and by using polymorphism and this dynamic binding, we're able to write clean, dry code. Dry is, remember, do not repeat yourself. So we're able to write clean code that is not repetitive, it's not redundant, and is written efficiently, yet it will have dynamic behavior such that it's able to accomplish the complicated specifications for the program. So this is yet another way in which object-oriented programming is able to provide better code. So then, putting it all together, an object of type person can call its own constructor, set name, get name, toString, and equals. An object of type student can call its own constructor, set name, get student number, set student number, reset, toString, and equals. However, remember, toString and equals both override the toString and equals methods defined in person. So we can use the super keyword still to be able to call the toString method and the equals method, which is part of the person class. Undergraduate can call its own constructor, setName, getName, getStudentNumber, setStudentNumber, reset, getLevel, setLevel, reset, toString, and equals. Again, toString and equals overrides the toString and equals from student, yet we can still call the toString and equals methods from the student class using the super keyword. We don't have to use the super keyword to call either of these reset methods because these are overloaded, right? It inherited the reset method from here into the undergraduate, so inherited student's reset method, but we also defined an overloaded version of the reset method, which has a different number of parameters. We inherited setName and getName into student, and then we also inherited it from student into undergraduate. So we have setName and getName, which we inherited from our person class. And we've also inherited our getStudentNumber and setStudentNumber from our student class as well. So these classes are inherited from person. They're originally defined here, inherited into student, and then continually inherited into undergraduate. So this is multi-level inheritance in action. Even though we only wrote these methods once, we're still able to make use of them in the student class. And then further, we're able to make use of them in the undergraduate class as well. So this is a way to eliminate redundancy and be able to reuse and extend already debugged code. These classes in blue are defined in the student class and then inherited into the undergraduate class. But remember, an object of type person cannot call getStudentNumber because it is defined in the student class. It doesn't exist at the person level. So even if a object of type undergraduate is stored in a reference variable of type person, you will not be able to call any of the methods which are defined in the student or undergraduate classes. Finally, in our last step of our multi-level inheritance, we have added the getLevel, setLevel, and a overloaded reset method. So only the undergraduate type can call these methods. Student can't and person can't. And then remember, when we're dealing with the overridden methods, the type of the actual object decides which of the definitions will be used. So if we assign a student object to a reference variable of type person and call toString, we will use this toString method, the toString method defined at the student class level, not the toString method defined at the person class level. So the type of the reference variable decides what methods are available to be called, while the actual type of the object decides which definition of the methods will be used. If the object making the call, so the actual object itself, is a person, then when the toString method is called, it will use the person toString definition. However, if the object making the call is a student object, then it will use the student toString definition. And also the same thing is true for undergraduate. If the actual object making the call is of type undergraduate, even though it's been assigned to a reference variable of type person, then the toString method, which is defined in the undergraduate class, will be used.